Hey mathematicians, welcome back to another lesson. We're doing 2.7 today about graphing absolute value equations. Everything about this lesson is going to be easier if you have a graphing calculator, and if you don't, what are you doing with your life? Make sure you contact your math teacher about how to get a graphing calculator today. Remember, it is a $10 rental, and we will, I'm sure, talk about that in the future. Let's talk absolute value functions. The idea behind these notes, and remember the notes are in the module before this, and if you don't have a printer, you can always take these notes on notebook paper. The idea is we're going to have this base function, and then we're going to talk about how the numbers, when they change in the formula, will change where that function shows up on the graph. So we have transformations, we have translations. Transformations change the graph size, the shape, position, orientation. So that they're the things that would take a graph and change the way it looks. Translations don't change the shape, they just move where the shape happens. So transformations usually involve multiplying by something. Translations usually involve adding or subtracting something. And so when we do this, we've got something we call a parent function. And this is the original. This is what it looks like with no bells and whistles, just the absolute value of x. And you can see what this graph does. It says, okay, I take 1, the absolute value of 1 is 1, graph 1, 1. Take 2, the absolute value of 2 is 2, graph 2, 2. Then I go negative, absolute value of negative 1 is positive 1, negative 1, 1. That's what the parent function does. And then when I add something in, like h, a number in there with the absolute value, it's a translation. So we're going to learn about h. H is the number that is trapped inside parentheses or inside absolute value brackets with x. H is a horizontal shift, and it always changes signs. So if this was negative 3, it would move right positive 3. It always does the opposite of what it says. K does exactly what it says. If K was positive 3, it would go up 3. So this number, this horizontal change, is always h, whatever that number is without the negative, so change the sign. And then this amount of change is k. And it's all going to depend on what the number is inside the equation. The vertex, which is this point right here, is the location h, comma, k, whatever those numbers are. So we're going to see this in action on this new graph. We know that it's translated the h units of the horizontal translation. We know the k units of the vertical translation. So if I've got this graph right here, that's where we're looking right now, h, k is going to be, okay, it says negative 2 is h. No, negative 2 is negative h. So we need to change it to positive 2. And then k stays the same, positive 4. This vertex is going to be right to up 4. And then the graph of absolute value, if I have not multiplied it by anything, it is up 1, right 1. And then it's also going to be left 1, up 1. And I would normally need to do a table, but we didn't do any other transformations, so we know that it's the same exact shape. And so for our comparison, it is the same shape, all shifted right 2, up 4. And that's where we're at. This is all shifted right to up 4. Now, if I said, you know what, Mr. Lambert, I don't know any of this. I don't know how to plug this in. I would say, well, let's just start by plugging in a point. So we could, if we plugged in 0, this again, if you did not know how to graph it, I could have said, okay, y equals 0 minus 2 in the absolute value brackets plus 4. And we would say, okay, 0 minus 2 is negative 2. And the absolute value of negative 2 is 2 plus 4. So y is 6. Plug in 0, go up 6, and that's exactly where that point is. So you can do it the old-fashioned way by plugging in and making an xy table, but because we had the parent function, we didn't have to do that. We said, oh, the vertex is shifted right 2, up 4, and then I just drew the same graph, shifted the same amount. Now it's going to be a little different on the next slide. We will have to do an xy table probably, but it's all because we have a multiplier. So there's a couple of notes with a multiplier. So if that multiplier is a number that is less than 1 but greater than 0, well, if it's between negative 1 and 1, so a fraction like 1/3 or negative 1/4 or something weird like 5/8, the graph gets compressed, which means it gets wider. It takes longer to stretch out. And then if the a number is greater than 1 or less than negative 1, so 5, 3, negative 6, things like that, the graph gets thinner. It goes up faster. And then if a is negative, it gets flipped upside down like that. So we have all of these possible changes, and this is where we're going to want to make a table. I'm going to make my XY table. And this one is going up by a half, so for me it probably makes sense to go by 2s. I'll just get a couple of points in here, no big deal. The absolute value of 0 is 0, 1/2 times 0 is 0. The absolute value of 2 is 2, 1/2 times 2 is 1. The absolute value of 4 is 2, half of that is 2. And we know with that V shape, because we didn't do any shifts, it's going to be the same on the way back up. So go left 4 up 2, left 2 up 1, and we can see the pattern. It's going to take 2, it's going to take twice as long to rise the same amount. So I've got, I switched to orange so it's easier to see. Connect the dots. And there's my graph. It got compressed, it got wider, it stretched out. It's like the V opened up more. This next one, I would recommend putting it in your graphing calculator. The way to find absolute value in your calculator is, it would be math, then the right arrow once, and then the number 1. Math right 1 gets the absolute value in. Okay, so then we're going to type this in our calculator, and I'm going to pull up an XY chart. Again, you're typing this into y equals, and then hitting second graph to get to the table. And I've got my table pulled up, so I'm going to go -2 down 1, 2, 3. Whoops, got the point there. 3, 4, 5, 6, 7. Better switch to orange so it's visible. Then -1, -5, 0, -3, 1, -1, 2, 1, which matches up with my H and K, and then back down. Going by 2s. See how this one's stretched? It actually is going to go, it rises faster than normal. That's because of the multiplier of 2. So the negative flipped it, and the 2 made it stretch. And if you are not sure how we got these values, there should be a calculator video showing you how to put different types of equations into your calculator, and you might need to review that. And then finally, we've got problems where we're going to be asked to basically do it backwards. We're going to be asked to look at the stretches, look at the changes, and then come up with the equation and graph it. So this one is reflected over the x-axis, which we know means it's going to have to start with a negative, stretched by a factor of 3. So we look back at our notes, we're like, stretch is a multiplier of 3. Translated left 1 unit, so h is 1, which means, negative 1, which means when it gets plugged back in, it's going to be the opposite. It's going to be positive 1. Remember how the formula is negative h, so negative 1 will be positive 1. And then down 2, and that one stays the same. K is down 2. It does not switch signs. So we know that we're going to have to change this one. So h is technically negative 1, but we're going to put positive 1 in the equation. So what this all looks like, we said it had to have a negative because it's reflected a stretch factor of 3. H is going to go into the equation as negative 1. Negative makes it positive 1. And then k is negative 2, and k never changes. That is the equation we're graphing. So I would pause, I would type this into my y equals, or I would start plugging in x values, but you do you. We're going to have x plus 1 minus 2, and I'm going to go to my table. And I've only got 5 points that'll fit on the graph. X, y, we've got negative 3, negative 8, negative 2, negative 5, negative 1, negative 2, which makes sense with h and k, 0, negative 5, and 1, negative 8. So we look, and we've got left 3 down 8. Better switch colors so it's more visible. And then this is all that's going to fit on my graph, is stretched even more, like a much steeper cone, and I've got my graph. So that's how we do absolute value equations. Your calculator is going to be your best friend. Please make sure that when we have an assignment, you have asked everything you need to ask from your math teacher. You ask us questions if you're stuck. We definitely want to help to the best of our ability. You have a homework assignment. Good luck, and please ask us whatever questions you need to ask us. Thanks.